Alright class, good morning. We are on to stem and leaf plots. We ended last week with doing graphical representations, the best ones to use here and there, bar graph, double bar, circle, line, double line, etc. So we're doing stem and leaf plots today, and it's a way to organize data that makes it, I think, easier to find the mean, median, and mode of a certain set of data. Okay, here we have the winning speeds, the Daytona 500. There's a lot of numbers there. It's kind of hard to pick out what is the mean, median, mode. They're not really in order if you're doing the median. So the stem and leaf plot puts them in order, kind of makes it a lot more straightforward to see what the mode is and also the median. The mean, the order doesn't necessarily matter because we're just adding them up and dividing. But let's see what a stem and leaf plot looks like. Should be review. Stem and leaf plot. What is this? Numerical data listed in ascending or descending order. Usually we go ascending order from smallest down to the largest, but it doesn't really matter as long as it's in order, ascending or descending. The stems are the greatest place value, so usually the tens or the hundreds, and then the least value is the leaves, so usually the ones. But sometimes it could be decimals like tenths or hundredths. Alright, so here's example 1. We have the adult dog weight in pounds of, looks like 16 dogs here, and I look at the data, and here's how I make a stem and leaf plot. Let's look at step 1. Okay, the stems are the greatest value, so I look at what is the greatest value for my stem. So I see some single digits, so that means 0 is in my 10 spot. Okay, and the largest one I see, I think, is a 2, in the 20s. Okay, so for my stems, I'm going to go 0, 1, and 2, because 0 is my smallest, 2 is my largest. Now, to do the leaf column, I order those from least to greatest, and then I need to write a key. Okay, I should also include a title. So, from smallest to largest, so from least to greatest, here's what my stem and leaf plot would look like. So I look at all my single digits. 4 is my smallest, then 6, then 8, then there's 2 9s, so you gotta write both 9s, even though there's 2 of them, you gotta write them all down. Then in my tens, I have a 10, I have an 11, a 13, 15, 17, 18, so on in the 20s. Alright. Here is very important, this key. Alright, we have to have this key in there. Right there, tell me what does this number represent and what is this one, because sometimes this could mean in decimal. Okay, it could be like 1.0. So when you do this, like the 2/6, what does 2/6 equal? Well, it equals 26 pounds. Okay, that's why we want to have the title and the key, so we can actually know what this data means. It's not just random numbers put together. Alright, so make sure we have a key on every stem and leaf plot that we make, and we title it. What does it represent? Alright. So this is very close to a stem and leaf plot. This would be incorrect because they're kind of in a random order over here. Alright, we want to put them in least to greatest order. Makes it a lot easier to find the median and also the mode because the numbers are right next together. Okay. If you want to practice one, here's some exercise times, and here's what the answer would look like. Go ahead and try that on your own if you want to practice putting them in the correct order. Alright, I guess I can leave it open so you can look at it. Alright, interpreting data. How do I use this information from a stem and leaf plot? Well, again, we're doing mean, median, mode, different things like that. So here's the number of softball wins various softball teams had in a season. Okay, they had the key, 2/3 equals 23 wins. So someone had 51 wins in a season, and the lowest team had 18. Alright, let's find the median and the mode. Well, fairly straightforward. These are in order. So the median, I'm just going to cross off until I get to the middle. We'll do that in a second. Let's do the mode first. So the mode, I'm looking for the most common number. So in a row, is there a number that's repeated the most times? So I look here, an 8, 2, 3, oh, there's 3 24s, 2, 4, 3 of those. Are there any other one that has 3? There's 2 of those, 2 of those, 2 of those. Nope, so that's the mode. 24 right there. Mode is 24. That's what makes these nice to use, finding the mode. Now the median, we're just going to start slashing. And these are in order. So I can just go in order. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. There's my middle number. What number does that represent? Well, it's a 38. So the median is 38 wins. Alright, and last question, what's the difference between the least and greatest number of wins? Well, I just said the least was 18, the greatest was 51, so the difference means subtract them. So 51 minus 18 should be 33. Okay, again, extra practice you want right here. Median mode, difference between least and greatest. Alright, then we have these things called a back-to-back stem and leaf plot. Now this may be new, but this is also very useful when comparing two things. We talked about double bar graph and double line graph. We're comparing two cities' high temperatures in this top example. But back-to-back, we use to compare them. We have to have two keys. Alright, so here, even though the leaves come first, this number here would actually represent 59. Okay. So this one's kind of read backwards on this side. This one's normal over here. So I can compare these two cities. It looks like, you know, the normal temperature in Portland is a lot colder. A lot of them are in the 60s here. And here, a lot in the 70s and 80s in Chicago. So Chicago is usually much warmer in June than Portland. That's kind of the general inference I can make from this data. Alright, notice there's so many 60s that they had to make a second row, so they just leave a space there. So I know these are all 60s still. Okay, you don't write another 6 down. Alright, so let's take a look here. We have a back-to-back stem and leaf plot. Not double one. A snowfall in Syracuse and Buffalo. Alright, in general, which city has the lower amount of monthly snowfall? Well, taking a look here. This Syracuse has a couple in the 30s and the 40s. Okay, this one doesn't have any over here. So to me, it looks like Buffalo has the least. A couple of 1, 1, 3, and 9, where there's more data up here. So my explanation is most of Buffalo's snow accumulations are closer to the single digits, while Syracuse is all over the place. Got some 30s and some 40s. Alright. Alright, which city has more varied amounts of snowfall? Alright, meaning which one has different ones? Well, Buffalo's all kind of packed down here in the bottom. Alright, Syracuse is spread out here. There's a 40, some 30s, some 20s, teens, and then single digits also. So there's a lot of variance. Okay, so you're looking for spread out if it's varied. Which one's more varied? And that's kind of where you can kind of look at, you know, what's the difference between the largest and the smallest. 40 down to 1, that's 39, is that spaced out? 39 different numbers, and here from 27 down to 1, that's only 26. So a lot less variance in Buffalo. Alright, so there's some things we can use for stem and leaf plot for. We can do back-to-back to compare them. We can also make our own. We can also find the mean, median, mode, the difference of the lowest and highest, which is actually called the range. So all sorts of things we can do. Alright. Hope that was helpful. Have a wonderful day.